Okay. Hello. Good morning, good afternoon, good evening, depending on where you are watching this video from, which time zone. Welcome to this webinar on career opportunities in engineering. My name is Somnath Banerjee. I'm an industry fellow. I worked in the industry for about 30 years, and now I have joined the academics and I teach. I'm the faculty in petroleum engineering and earth sciences. Although I teach petroleum engineering, I did my graduation from BITS Pilani. I'm originally electronics and electrical engineer. All right, so let's see what we have in today's agenda. Before we go into the engineering careers, I would like a small introduction on UPES. Those of you who are not fully aware of the history of UPES, UPES stands for University of Petroleum and Energy Studies. It was formed around 2003 and it started off with petroleum courses and management courses. It was the first university which was recognized by UGC as an energy institute, and it was also a core sector university in Asia, the first core sector university in Asia. We started off pretty humble, about 250 students and 50 faculty. Over time, more and more programs were added. A school of law was established, which had an accreditation with Energy Institute of UK. We got accreditation from NAAC, also called NAC, and the student strength rose to around 3,000 plus. Around 2010, there was a collaboration with IBM. UPS and IBM, when they collaborated, they kind of, as a part of that collaboration, they designed most of the IT courses. Some of these courses are actually delivered by IBM faculty who visit our campus, and not only they design the courses, they deliver it, they also certify the students as part of the course itself. Then in 2011, UPS ventured beyond petroleum and energy sectors. We looked at management, we looked at law, and then the School of Design Studies was established in 2013, which brought in architectural design, etc. And today we are fairly big, although located in Dehradun. We have two campuses, and the total area is around 45 acres. There are 80 plus programs, 100 plus labs, 12,000 plus students, and 540 plus faculty. So over time, the description of UPES has kind of evolved, and from University of Petroleum and Energy Studies, it is now UPES with this new logo. All right, as things get bigger, it becomes necessary to make a proper division so that it's easier to manage. So the University of Petroleum and Energy Studies has 5 schools under it, and we have the School of Engineering, which offers BTech and MTech courses in engineering. We have School of Design, we have School of Law, School of Business, and School of Computer Science. Naturally, the School of Computer Science is mostly focused on IT, and we have collaborations with IBM, with Xebia, etc. So I'm going to talk about the School of Engineering because that is where the petroleum engineering from which I belong, it belongs. And since the purpose of this particular presentation is more about talking about engineering as such, we will keep our discussion to School of Engineering. Within the School of Engineering, we have 8 departments, and these 8 departments are offering 14 programs. When we say programs, these are usually BTech programs, like for example mechanical, petroleum engineering, etc. And we have 4,500 students plus students, about 270 plus faculty, and 16 student chapters. For those of you who are not aware what exactly is a student chapter is basically a collaboration with the industry organization. For example, the petroleum engineers have a international organization called the Society of Petroleum Engineers, or SPE. This is an international organization, and the petroleum engineering in the campus has a student chapter which is linked to the SPE International. By the virtue of this particular student chapter, you can get access to a lot of activities within that particular area. And similarly, for example, mechanical, they have a student chapter under SAE. So like this, different programs have different student chapters, which are usually international organizations. All right, so coming to the School of Engineering, I said we have 14 programs. These programs are listed on the left hand side. I will start with the Applied Petroleum Engineering with specialization in upstream. This was this is the oldest program run by the university. In fact, when the university started, this was the first program which was offered. Then we have Applied Petroleum Engineering with specialty in gas. As you have seen, when the hydrocarbons market evolved, there is more and more focus on clean energy and gas, use of gas. We are today using CNG, we are using PNG. So this need has basically evolved a new industry, which is the gas industry, and therefore the university has offered a program which has got specialization in gas. Then chemical engineering with specialization in refining and petrochemicals. This is pretty much standard. I'm going to talk about it later on when we talk more into the description of each of these programs. Then you have geosciences, which are basically geology, geophysics, etc. We have geoinformatics, which is something like easiest application I can think of, which you may be aware of, is the GPS. Like today when we drive, we have a GPS device. Most of us have a GPS device either on our vehicles, or we use the GPS of our cell phone. And if you look at it, that's also a technology which is taking time measurements from satellites, computing some results, putting that results into a database, which is usually a map, and then pretty much showing you where you are moving or where you plan to go. So this is an application of a technology which is something which has been there, and this is a part of geoinformatics. Then we have mechanical engineering. We'll talk about that. It's pretty standard, has been there as one of the core engineerings for a long time. Then we have mechatronics, which is a new field, or a relatively new field, where we kind of have a collaboration between mechanical, electrical, electronics, and robotics and communication, and bring together a new dimension to mechanical engineering. Then we have automotive design. So if we go through that list, I would say number 1, number 2, number 3, number 4, and 5. These 5 programs are offered by the petroleum engineering and chemical. Then we have the mechanical engineering and mechatronics and automotive design offered by the mechanical engineering department, aerospace and avionics being offered by the aerospace department, etc. So we have 8 departments offering 14 programs. Now I will go through each one of these programs later on. So let's move on and see what we need to talk about. Okay, so in this particular slide, we have shown what is the process to get admission into UPES. There are 2 ways. One is called the exam pathway, which has up to 80% seat distribution, and which has a minimum criteria of 60% marks in 10th and 12th, 60% aggregate in PCM, and you have to appear for the UPS engineering aptitude test and get a score. Then there is the non-exam pathway, which has got 20% seat distribution, and you can have come through either board merit or through JEE main scores, and again it is mentioned what are the minimum requirements. And over and above that, we have 15% reservation for Uttarakhand domiciled students, because the university is registered in Uttarakhand. Alright. So Doing an engineering course in UPES is a little bit different from doing an engineering course from any other university or most other universities. Why? Because in UPES we have developed specializations. Almost each engineering course has been tailored and refined into a specialization which we believe gives an added advantage to the student. So, in order to do these specializations, we have collaborations with the industry. So that means one of the top leaders of the industry in which the particular engineering is offered is collaborating with the university. And when we say collaborating, it is they are co-designing the course itself, they are bringing in the latest technologies, they are even delivering the course with their faculty in our university, and they are also certifying the students before they step into the industry. So this kind of a methodology has helped UPES students get better traction in the industry, especially in terms of jobs. For example, you can imagine if one of the students who is doing, say, computer science is doing a course which has been designed by IBM, which is designed to reflect the latest needs in the industry and is certified by IBM, it is a good chance that after the course is completed, after the program is completed, the student may want to join IBM. So it's a win-win situation for both the industry and the university students. So we take pride, or the UPS takes pride in having several such collaborations. Some are national, some are international, and some are memorandums of understanding. For example, in this particular slide, I'm just giving an example of three of them. Larsen and Toubro. It's a name well known in civil engineering, and they are the construction company. They have been the construction company for a long time. So very well respected name in Indian industry, construction industry. So we have a collaboration. The civil engineering department has a collaboration with Larsen and Toubro. Naturally, the students get a chance to go to Larsen and Toubro field offices, understand the field operations, actually work in real time operations, and learn much about the industry. For example, what they learn in the classroom, they can immediately go to the industry and see its practical applications. Similarly, another name is given like Cisco. We have probably heard of Cisco routers. They are a name which are a big name in IT industry and in electronics. So the Department of Electronics Engineering has a collaboration with Cisco, and therefore as part of that particular collaboration, Cisco designs some of the courses. The students go through some of the Cisco certified programs and go through Cisco certification. Naturally, when they come out of the program, that means they finish the program, they stand a good chance to join the industry with a known certification. Similarly, we have Philips Carbon Black. Philips Carbon Black is a very big name in chemical industry. In fact, they produce most of the carbon which is used in industry in India. And Philips Carbon Black has a collaboration with the chemical engineering in UPS. And again, the students, by virtue of this collaboration, get an advantage in terms of internships, in terms of projects, in terms of placement. So this is basically the methodology which is being used by UPS, where almost each department is having a collaboration with one of the industry leaders so as to give that value to the student. Now, most students, after they finish their 12th exam, are wondering what to do next. Well, during my times, say 35 years back, I was also in the same situation. But in my times, things were very simple. There were only two or three things to do. You either choose being a doctor or being an engineer, or you go into humanities, etc. But life has changed, industry has changed, technology has changed. Today, I believe it is much more difficult to make that choice. In our times, we were pretty much free to learn basic engineering, and then once we have learned the engineering, choose our career. And there was not too much to learn. Unfortunately, in today's times, the amount of knowledge which is there has expanded exponentially. The amount of choices which are present are also have grown up. No more it is just a doctor or a lawyer or an engineer. You have now so many different professions, and each claiming to be best. So it becomes difficult to make a decision. And that too because, as I mentioned, the amount of knowledge has increased exponentially. In order to learn anything now, you need to be very, very specific and focused on one particular part of that entire knowledge. What I'm trying to say is that when our times were there 35 years back, we just learned basic engineering. And then as time moved and as we progressed, we kind of found our way and then found our slot that, okay, this is the thing which I like to do and this is the thing which I want to do in my future. Unfortunately, that luxury is not available today. Unfortunately, you cannot just do an engineering and then wait and choose that okay, I will like to do this and I will like to do that, because the amount of knowledge required has become so great that you have to choose, make that decision pretty much beforehand, right now, like after your 12th class, to decide what you're gonna do the rest of your life. This can be a very scary thing, especially if you are not fully aware of what the choices are. Every person will try to claim that their choice is the best or that their offerings are the best, and there will be other factors like parents, pressure from friends in order to make a choice, and pretty much you will be wondering what to do next. So the purpose of this particular webinar is exactly that we would like to tell you what the choices are, and we would like to share with you with our own stories. For example, I have spent 30 years in the industry. I am an engineer. So what all did I learn? What all did I like? What all I did not like? So I will be absolutely honest with all of you to tell you what engineering basically offers. So let's try to figure it out and see why should a person go for engineering, especially when there are so many different types of professions, including journalism, mass communication, and stuff like that. Well, I have been an engineer, so perhaps my views may be a little bit biased, but even then, I would strongly say that engineering is not just a degree. When we talk about engineering, we are talking about a way of thinking. It is almost like, when science came into the world, people developed a concept of science, people developed a new way of thinking. Similarly, engineering is a way of thinking. You will notice that people who are engineers generally tend to analyze issues, tend to build things, tend to create things. It is just that they are trying to put together ideas from different places and giving a shape to a new solution. Then, for example, let's take any product today which we use, the iPhone, the one which is perhaps the most popular product today. So when we look at iPhone, we look at it from all different ways. It has got some technology, which is 3G, 4G kind of technology. It is using plastics. It is using metals. It has to be manufactured. It has to be fabricated. That will require production engineering, mechanical engineering, electrical, and it's got electronics. That will require electronics engineering. It has got design features. It looks good. It looks pretty. So that will be aesthetic, design. So many different aspects of the same product. And then when all these different aspects are right, you have a successful product. Same thing is true of perhaps all the products, that in order to make a product succeed, every different aspect of the product has to be right. And that is where engineering comes in. You must have seen that we will be talking about mechanical engineers, electrical engineers. Each person from different engineering contributes his part in making into the product. So it's actually quite fun and interesting to see how a product is conceived, how it is designed, how it is fabricated, how it is tested, and ultimately how it is marketed and it successfully works. So this whole process can be seen from the eyes of an engineer in a totally different way than if you were not an engineer. Okay, then engineering, what else does it bring in? In my view, engineering gives us a balance of knowledge, a balance of skills, a balance of attitude and habits. Let me give you an example what I mean. Let's say you are driving a car and you had a flat tire. Well, if you are in a city, it's not a big problem. You just park your car to the side, and if you are an engineer, you probably will jump up and go to the dicky of the car, take out the jack, take out the stepney, and will be ready to change the tire yourself. So, when there is a flat tire, what you need to do next is the knowledge. For example, if you know that, oh, I have got a flat tire, now I need to change that tire, and I know that there is a jack and there is a stepney in my dicky, then that knowledge, that, that awareness is knowledge. But then comes a skill. Fine, you know what is to be done, but can you do it? For example, do you know where to put the jack and how to lift the car? Do you know how to safely put the jack so that it does not roll? Do you have strength to move the spanner safely and take out all the nut bolts and change the tire? So those parts will be the skills which which gives you the ability to apply your knowledge and actually do something. Then the third aspect is attitude. Attitude is that fine, I know what needs to be done. I can do it. I have the strength to do it. But then do I want to do it? For example, if you are in a city, why would you like to spoil your hands, make them dirty, when you can just call a mechanic, just give him a cell phone. Cell phone technology is there. Give him a call, he will come and change the tire. That is pretty much attitude. And then finally comes habits. Habits are things which are kind of ingrained. For example, there is a safety habit. For example, driving habit. Some people are rash drivers. So, when you talk about engineering, you will see that success generally comes to those who have the right balance of knowledge, skills, attitudes, and habits. This is what I have seen, especially in the oil and gas industry. Then in engineering, there are diverse career options. And as I mentioned to you, with every engineering, there are certain common aspects, common courses, commonalities, and then there are specializations. So sometimes it enables a person to change tracks. For example, I was giving you my own example. I did my electrical and electronics engineering from BITS Pilani, and initially I was doing a job in a hardware company, electronics job. But then, but then, guys, excuse me, there's some noise from the background. Sorry for that. There are some students who are talking too loudly. Okay, thank you. So, so I started as an electronics engineer, but then I joined the oil and gas industry. And then for 30 years, I am in this industry. And during this 30 years career, I have done pretty much a little of everything. For example, I have designed mechanical systems, I have designed trucks, I have worked on software, I have worked on hardware. So the good thing about engineering is that yes, you learn some basic stuff, and then using those basics you can maneuver and find your own slot. And as I mentioned today, I am teaching petroleum engineering to the students in UPES. So it's diverse. Then it has got quick growth prospects. Definitely, I will say this 100%. Compared to other professions, engineering professions has a higher growth. Not just because the industry is growing, it is because the industry has a lot of demand for engineers, and there are not many good engineers available. So naturally, those few who are good in their job tend to grow very quickly in this industry. Then it is a well-paying profession. I mean, uh, I have I will say that during my 30 years of career, I have been able to kind of um, complete all my dreams. That is, make house, have a car, get married, do all the usual things, have enough savings, and not to bother too much about what is going to happen next. So it's a well-paying profession. It's a well-respected profession, and engineering leads to numerous innovations. Well, as you have seen over time, these small gadgets, every now and then a new thing is introduced. Today we are talking about virtual reality, artificial intelligence. There's always a constant flow of new ideas coming. All these things are being led by engineering. It has the potential to make India lead the world in future. I say so because I have seen this. I have worked in many different parts of the world. I worked in more than 25 countries, lived in many countries, and I have seen the differences in education, differences in perception in different parts of the world. One of the biggest benefits, or the biggest advantage of India today, is that a large part of the population of India is young, and that gives us the energy to do things. So, in a world where the population is pretty much declining and the working age of the population is kind of becoming more and more, so, for example, Japan, they have a very high percentage of population which has become old, and other countries also. So, India, from that point of view, stands in a very good chance to make a big difference in terms of innovation, in terms of engineering leadership. And if we can actually get into this engineering, do all those things, design new products, design new technologies, we should be able to lead. And instead of following, and instead of just using products, we should be designing new products, creating new technologies, and making them in India for others. Then engineering is the ultimate field of challenge and creativity. Well, as I mentioned, in engineering you have to do things. You have to be in the field sometimes. You have to see real life problems. And when you see real life problems, not every problem has a quick solution. So sometimes you work on these problems for quite some time, but eventually you keep on trying. One solution doesn't work, try another one, and eventually you do make success. And through that process of learning, there's a tremendous satisfaction one gets when you solve a real life problem. For example, today's problems could be climate change. Today's problems is greenhouse gases. I'm sure if some engineers can think of some ideas, find out a way of capturing this carbon dioxide and putting it inside the earth, or putting it inside some kind of a containment, that could be a solution for the future. That could be a good engineering solution for the future. Similarly, people are talking these days about solar energy, and people are talking about electrical vehicles. Just imagine, you are right now going to be part of a generation which is going to design or redesign the whole technologies. For example, the people like us who have been using petrol driven cars and petrol driven cars and diesel cars will have to change to electrical cars. Just imagine how much potential that has, and how much, I mean, in terms of technology, what all needs to be done to bring that kind of a massive change. Then the engineering has got great rewards and opportunities. As I mentioned to you, I worked in the oil and gas sector, so I pretty much visited several different parts of the world, worked in several different places, several different environments, got different types of opportunities, and I kind of enjoyed that. And the last not but the least, it opens new career options for women. I want to make this point now because I have seen these changes. 30 years back when I had joined the oil and gas industry, it was pretty much a man's industry. I mean, there was hardly a woman to be seen because the industry was somehow not designed for that kind of I mean, what was designed for accommodating women. So, but over the last few years, I have seen so many changes. In fact, I keep mentioning this story that when I was in Alaska, I was in a rig, an offshore rig, where the drilling manager was a girl, and I still remember that how wonderfully she was managing the whole crew. Alaska, as you know, there was freezing temperatures, minus 40 degrees C, and it was a very hostile kind of environment to work in. Yet she was doing it so well. I was so impressed. And what more was that there was no issues of men feeling as if they are being bossed. No, I could see that the crew was very happy. They were very well managed by this particular girl or this particular lady. So having said that, I want to basically tell this thing to all the women also, that do not look at engineering as something for the boys only. Engineering has got lots of scope for women. Yes, women may not have tried out all the different ones, and there is going to be some learning in the beginning, but it has pretty much a lot of challenges, excitement, and fun. And as more and more success, people get more and more success, we will see more changes coming into the industry. All right. So, having said all that, naturally now comes the decision. Okay, so let's say I want to do engineering. Now comes the question, which engineering? And as I mentioned to you, that in today's world there are so many different types of engineering that it is pretty much mind-boggling to figure out which one is right for me. And in the beginning, especially, you yourself do not know what you are good at. So it is possible that you may take a risk and pick up something and later on discover that it was not the right move, and then you may have to change. Well, all that is there. I mean, that is part of life today. But having said that, as I said, the purpose of this particular webinar is to educate people who are about to make this decision for their life, give them the right options, give them the right choices, and help them making a choice. So in this particular webinar, what I've shown here is that the typical type of things which happen to a person. For example, there is parents' influence, there is relatives, there are friends, then there is a changing market, and many a times you come across a dilemma like which one should I do. For example, if you are getting a not so good branch in a very good college versus a good branch in a not so good college, which one should I choose? My opinion would be that you should definitely choose the not so good branch in a very good college. There is a reason, and I have mentioned this several times to some parents also who I have met during counseling sessions, that one of the biggest advantages of UPES is that several big companies come to the institute for recruitment. This gives the opportunity for all the students to look at better careers. I mean, what is the point of doing a engineering in a college where where you have to fight for placement, where there are no companies coming to recruit? So in UPES, even if you have got a engineering which is perhaps not your first choice, but maybe second or third, it perhaps is still good, because in UPES one of the things which is there definitely is that almost all the leaders in the industry are coming for recruitment. Okay, so given this background, now I will come to the career opportunities which are available in engineering. So we will go through that entire list. If you remember, in that list there were 8 departments and 14 programs, and I have put a slide each on each of the departments. So there is the petroleum and earth sciences and chemical engineering departments, which offer several courses, and these courses are related with mostly oil and gas. Well, To those of you who are not aware of oil and gas industry, let me explain a little bit. As we know, most of the oil is found, or the hydrocarbons is found deep inside the earth. So the first job is to find out which part of the earth has the potential of having hydrocarbons. Then we have to find out a way to get to those hydrocarbons and bring those hydrocarbons to the surface. So this science or the industry whose job is to look for hydrocarbons to bring that hydrocarbons to the surface of the earth is called upstream business. So the oil and gas business is divided into upstream and downstream. Upstream is when we are looking for oil and we are bringing the oil to the surface. Once it comes to the surface, then depending on the nature of the fluid, for example, if it is crude oil, it has to be sent to a refinery for processing. Or if it is gas, then it has to be sent to a gas handling plant. So depending on the hydrocarbon, there are downstream industries. One is the refining industry and processing industry, and the other is the gas handling industry. And again, you have carriers in those. For example, you must have seen these days in lots of cities they are using piped gas, PNG. Now when you are using piped gas, you have to have a complete infrastructure for getting the gas from some natural resource and then distributing it, metering it, and charging for the gas. So it's a whole industry in itself, and we have a course which is called Applied Petroleum Engineering with specialization in gas, focused on this particular part of the industry. Then, as I mentioned, depending on the fluid which comes out from the earth, if it is crude oil, you have to do processing, and processing and refinery is another industry. So again, we have a engineering program which is designed exclusively for that. And if you look at it today, if you look at any product, name any product which is available, you will see that somewhere or the other there is some link to a petrochemical industry. Either it is plastics, or if it is even simple products which are shampoos, lipsticks, cosmetics, everything will have some kind of a petroleum product. So naturally there are different industries and different engineerings, and one can pursue those careers. So in this particular slide, I have mentioned some of the many careers which are available in oil and gas. For example, the typical careers in upstream business are geoscience engineer. For example, as I said, the first part of oil exploration is trying to find out where is it possible to have hydrocarbons. That is done by a process called exploration, and that is done by geoscientists. So you can look at a career like that. It's very interesting. Then you have geoinformatics engineer. For example, I gave you an example of GPS. It is just one of the many things which we do in geoinformatics. Today we have so many satellites, they send so much data down, and using that data we can pretty much map the reservoirs. We can use various kinds of applications to hold the data and view the data in different ways. So all that comes under geoinformatics. Then we have drilling, the standard drilling. So as I mentioned, once you have located a place where there is a possibility of hydrocarbons to be produced, then our objective is to check whether indeed it has hydrocarbons or not. So in order to make that final confirmation, we will have to drill a well. So drilling is associated, and lots of jobs are available as drilling engineers. Once drilling successfully discovers a reservoir, then our job becomes to complete that well and make it ready for production. So we have production engineers, and we know that these oil fields are pretty big. Sometimes they produce for hundreds of years, sometimes they produce for tens of years, and sometimes they could be as less as few months. So depending on the size of the field, the size of the reservoir, you have to design your production. All that part comes under production engineering when we start producing. So the typical oil field related careers are the ones I have mentioned over here, but there are many more. So once these hydrocarbons are brought to the surface, they need to be processed into finished products and marketed. This part of the business is called downstream, and again there are some standard careers available here like pipeline transportation engineer, petrochemical engineer, process design engineer. These are pretty involved, and I mean, one might think that this is, uh, I mean, like uh, most people do not have an idea of how things are actually made. They just see the final product, and they sometimes don't even care to know how that particular product was made. And sometimes we ourselves do not give it so much importance. But we should not forget that each and every product is made by some means. For example, somebody must have designed it, somebody must be manufacturing it. Even if it is robots which are manufacturing it, it's ultimately somebody manufacturing the robots. So in every design, in every product, there will be some engineering which will be associated. Then, apart from these kind of hardcore oil and gas related careers, there is a new domain, or there is a new field which is coming up and getting very popular, which is the software. Software for oil and gas. So we have several companies now which come to our institute and hire petroleum engineers, geoscientists, geoinformatics people for software. And one would wonder that why would a petroleum engineer do software? Well, as you have seen, the nature of the industry has changed. For example, before we make a product, in reality, before we make a prototype of the product, that product is first designed in software. There are several types of software available where you can pretty much test the product for different types of inputs and see how it behaves, how it reacts. So similarly, there are simulation softwares. For example, if you were to learn flying an aircraft, there are flight simulators. Most of the pilots learn their basic training in flight simulators. Just like that, there are drilling simulators. That means even before you have actually drilled a well or even started drilling a well, you simulate the entire well. You simulate each and every step of the well and see where are the chances of failure, which are the areas which could create problems, and therefore you plan for a mitigating solution in advance. So a lot of industry has grown in this way, and which have basically there is high demand for engineers in this kind of a software domain. So overall, pretty interesting. I mean, this particular engineering department has got fairly high, above 95% placements numbers, and most of the petroleum engineering is almost 100%. I will come, one moment, I will come later on the kind of companies which come to our university for recruitment. But as I mentioned, almost all the leading companies in that particular industry come to UPES for recruitment. Then we come to the next department, which is the electrical engineering and electronics engineering. Now, both electrical and electronics engineering are pretty much standard. I mean, they have been the way like that way for quite some time, and they are perhaps offered in many different universities. So one would wonder, what is it that would interest me now? Well, think of it. Think of it where you are, at what point in time you are. We are today at a time when a large number of vehicles are going to become electrified. For example, Prime Minister Modi has already announced that in future all vehicles are going to be electrical. So just imagine the kind of potential that creates. in the infrastructure which has to go into electricals. You have to have electric vehicles, you will have solar and other renewables, you will have smart grids. All these things are picking up and gaining more and more momentum. Then, did you know that India is currently the second largest telecommunication market and has the third highest number of internet users in the world? Well, apart from the electronics manufacturing, India is also pretty much poised in the right way in several things. For example, Internet of Things, broadband and 4G, embedded systems and digital signal processing, artificial intelligence, electronic design automation. So all these new subjects are coming up and they are providing a excellent and very exciting and challenging opportunities for people who are about to join engineering. I mean, I am myself very excited to see how the changes are going to take place over time, where a standard, I mean, where we have been so used to a standard way of looking at things. For example, a car was always a petrol car and now it's going to be electric. So we will see how that goes. It's going to be very exciting. So there are several such careers available from electrical and electronics communication engineering. Then coming to mechanical engineering, and especially automotive mechanical and automotive and mechatronics engineering. So mechanical engineering is pretty much the same what has been. I mean, if any product has got parts and those parts move, it must be having some kind of mechanical engineering input. Some of the products which we know and we use every day are the automobiles. So there is a specialization on automobile engineering. And then there are mechatronics. Okay, the things like which involve a combination of mechanical, electrical, electronics, especially a little bit of software, communications, everything put together, then that is called mechatronics. So again, there are exciting careers involved. So let's give an example. Again, coming back to that example of electric cars. If we have to change all the cars of India from petroleum or based products to electric, and all the vehicles like buses and trucks to electric, the amount of mechanical engineering which has to go in, the amount of electrical engineering that has to go in together, just see the potential. And India has actually taken the lead on these things. I mean, it is no more the follower, it is in fact has become a leader in these kinds in this particular area. So the chances are that we will be, if we do it right, we will be having a much better grasp of the industry and we will be leading in this industry. So again, a lot of excitement over here. The typical jobs are engineering design services, manufacturing of machines and machine parts. This has been the traditional ones. Then automotive engineering, computer and electronics product manufacturing, industrial automation engineer. This I believe is the trending one, and robotics. Because as and when more automation takes place, we will be moving more and more towards robotics, and that will be very interesting because in order to design new stuff, you will have to design new robots. So that will be another interesting way of exciting way of doing things. Then coming to aerospace engineering and avionics. Well, most people think or know UPES as a petroleum engineering institute only. Many people do not know that we offer several other engineerings and each one of them are actually quite good. In fact, the aerospace engineering students recently had received a award, an international award called CANSAT. It's a global international award from CANSAT as the only or the first college to give their prototype and win it in Texas. So these guys are also, I mean, these students are also learning something new. So, given that background, let me say that India is set to become the third largest aviation market by 2020. 2020 is not very far away. So, we need to plan for that. And the joint venture between Boeing and Tata Advanced Systems in India is going to co-produce the Apache helicopter. So, again, a lot of military requirements are coming up and a lot of production of aircrafts is going to take place in India. Rolls-Royce has established an engineering center in India to train 1,500 local for defense aviation business. So this business, which has traditionally been, just import the aircrafts and maintain them ourselves, is now going to change to manufacturing these aircrafts, uh, designing these aircrafts, and using the latest technologies in this. So again, a tremendous opportunity exists here. Typical careers are aircraft design and analysis engineers, and the recruitment companies which come for recruitment are Airbus, Rolls-Royce, Boeing. So these are all big names in aerospace. So you can see again a very exciting career over here. Air defense system engineer. So that's another important or interesting career. Aircraft maintenance, as mentioned, Rolls-Royce is establishing the centers over here. Then satellite and space systems engineering. This is pretty much to do with avionics. Avionics is the instrumentation or the electronic part of a aircraft, whereby you communicate with satellites, you communicate with different systems in order to find out your special. Uh, it basically tells the aircraft what all is going on, where it is located, where to go next, etc. So all that is in avionics, and that is also another very interesting engineering. In the past, in during my time, say 35 years back, all these were not available. These were usually only in very developed countries. These kinds of engineering were not even known. People used to go out to learn these things, learn all these things in abroad, and then perhaps come back to apply these things in India. Today, things have changed. All these engineerings are now offered in India, and they are now being offered in UPES. Then coming to civil engineering. Well, this is a bread and butter of engineering, has been there for a very long time, has been the oldest of engineerings and perhaps the biggest of engineerings. It employs more than 35 million people, second largest after agriculture sector. Because that is true. I mean, when we talk about civil engineering, we sometimes think that that is all making just houses. No. If you see, our Prime Minister has been talking about smart cities. Smart cities are designed in such a way so that they are efficient, energy efficient. People do not waste time traveling and commuting. People are able to access almost all the different functions in a very smart and efficient way. So saying smart cities is something, making smart cities and actually implementing them is a whole new thing. And as we see the world is going more and more towards environmental friendly technologies, environmental consciousness, it has to it has to find out new ways of doing the same things in a much more efficient way. So again, I would say that this also holds a lot of challenge. I mean, the construction is there everywhere. You have seen ports are being constructed for import exports, roads are being constructed for better transportation, more efficient transportation. uh, Smart cities are being designed so as to replace our conventional way of designing it and making it into a much more efficient way. So again, a lot of careers are available over here: structural engineers, transportation engineers, water resource engineers, geotechnical engineers. What is geotechnical? So, well, some of you may not be able to get an idea of what geotechnical is and why geo is so important. Let's look at a simple example. If you remember, if you remember about 10-15 years back, the distance from Bombay to Pune, I mean, I have driven that road myself. About 15 years back, it used to be such a pain. There used to be trucks lined up on the roads, and there was just about one working lane in which large number of traffic would go through, and it was so much time consuming. Today, if you see, that same road has been made into an expressway with something like 3 or 4 lanes. And today, the time taken from Pune to Bombay is so less. So one would wonder, okay, so what big deal? You just made a big road. No, no, no. It is not so simple. Just making a road is another one thing, but making a road on a hill is a different story. You have to know what are the strengths of the rock. You have to figure out which is the best way of making a tunnel, which is the safest way of making a tunnel, the safest way of making a road, so that the road remains a road. It does not get destroyed by earthquakes, it does not get destroyed by debris rolling down from the top of the mountains, etc. So that is the place, that is the area where geotechnical knowledge comes in, and that's why it is mentioned over here. So then architectural engineering, environmental engineering, and construction engineer, they're pretty much, some of them are standard, some of them are new. So as you can see, there is a host of careers which are available, and but not the least, fire safety and engineering. This has become very, very important. You see, almost any industry today, any, as long as it is hiring more than say 50 persons, it is required to have a safety officer, and by law. And in oil and gas, it is even more important, especially those engineerings where there is more risk involved, especially when you are handling materials which could be inflammable. There is more risk involved. You have to look into fire and safety. So this is another very interesting engineering, and don't get confused by thinking as if this is the job of a fire brigade man. No, no, no. This is not that. When we talk about an engineering job, we are talking about a designing of a system which can be implemented in an industry to make it safe or safer. And that is a different thing. It is, what I'm trying to say is that the job of a fire brigade man or a fireman is to take this truck to the place where there is fire, take out the hose, put water, and somehow control the fire. That is the job. The job of an engineer who is in fire safety engineering is not this. The job of an engineer would be to design the next fire extinguisher, or the best and most efficient fire extinguisher, to design a method by which fire alarms can be set up safely and have a backup system. So the job of an engineer is pretty much into thinking what is the best way of making that industry safe. I mean, for example, even simple things. We look at gloves. Okay, we all know gloves. Did you know that there are more than 100 different types of gloves just in the oil and gas industry? Why would one would wonder, Hore, why would you have so many different types of gloves? The reasons are because you handle different types of materials in different types of environments. For example, if you are handling a chemical, you need to have a rubber glove because latex material is perhaps the most insensitive to chemicals. If you are using something inflammable, you cannot use a glove which can catch fire. So you cannot use a fabric glove. So you use something else. So the point I'm trying to make is that thinking what is the right product for that industry which will make it safer is the job of an engineer, and that's quite interesting. And I mean, I've been involved in some of them. It's pretty much a nice career. So again, typical careers are manager of fire and safety, fire safety officer, industrial fire safety engineer, and oil and gas health safety and environment officer. So with that, we have pretty much covered the different engineerings which are offered at UPES, and we have covered the different types of careers which are available. The ones which I have shown are just some of the more important ones, but there are other careers. Just because I am covering a lot of different types of engineering, there is just not enough time to go through each one of them in detail. However, I can take questions in specific engineerings later on. Okay, so one of the things which sometimes is a cause of worry is that, does engineering provide enough growth? Does it have a future in India? Stuff like that. Well, as I just mentioned to you a few minutes back, that India has 2-3 good things going on right now. Number one, it has a sizable population which is young and energetic and has the ability to do things. Two, it has developing an infrastructure which is good for business, taxation, imports, exports. And three, it has that Make in India initiative where we are trying to get technologies and getting the products made in India. With all these three put together, I would say that the future of engineering in India is far better and probably robust and consistent. It is not like a bubble which is going to just disappear one day. So if you look at the figures shown over here in terms of market value, in terms of billions, it's plenty and it's growing. And it will perhaps keep growing at a steady state for at least the next 5-6 years for sure. After that, maybe something else may happen, or we will have to see. But at least with the data which we have today and the predictions we can make, engineering is definitely a very good potential growth sector for in India. The top job trends, this is some data which has been taken out from internet, from the Confederation of Industries. It is telling you the growth and employability of some of the sectors. As you can see, auto has grown 23%. And as I mentioned to you, the switch from uh, petrol driven and diesel driven vehicles to electric driven vehicles will make this industry grow even more. Construction, yes, we have been seeing development of metro networks, development of smart cities. So again, it's already at 22%, will probably get even higher. Industrial products, usual, it's right now at 11%, but I have a suspicion it will be also another, it will grow into 20 plus very soon because of the initiatives taken by the government. And oil and gas, despite what people say that about oil and gas, that oh, the oil and gas market is going down. Well, it's actually not gone down, it has increased by 11%. Our placements have not gone down. In the last 2-3 years also we have had almost 100% placements. So as such, all the trends look positive for engineering, and therefore I would encourage you to choose that as a career. Here are some of the trends which will help you to perhaps make a right choice: IT, telecom, robotics, manufacturing, BPO, banking and financial. BFSI is banking and financial, FMCG is fast moving consumer goods. All these different choices are available, and as you can see, there is a higher demand and there is less of supply. So naturally, if more engineers are available, we will have much better growth numbers. Okay, so lastly, this is perhaps the last slide. I would like to give you an idea of the placements at UPES. UPS is proud to say that despite the market slowdowns and what is affecting the global industry and Indian industry, our placement trends have been actually quite good and getting better. We are overall, for the entire School of Engineering, our placement efficiency is 91%. The figures which are shown here are the students. The ones shown in orange with white font are the students placed, and the ones shown in gray are the total number of students who were eligible for placement. So as you can see, we have been in healthy 90s. In fact, in some of the engineerings, we are more than 94-95% also. So overall, I would say that engineering career is perhaps a good choice, especially at this point in time in India, because of the tremendous impact of several things which are going to happen very soon, and we know they are going to happen. For example, the change from petrol driven cars to electric cars, the introduction of smart cities, construction, the introduction of artificial intelligence, automations. These are the things which are going to be driving the future. Here are only some of the companies which are shown over here. as our prominent recruiters. There are many more, and if somebody wants details, I can spend some time on that later on. But there are almost more than 1200 companies which have hired from UPES in the last 2 to 3 years. So with that, I would say you are in safe hands. Even if you do not get your first choice of engineering and you get your second choice, perhaps it will be a good idea to pursue a engineering at a better university or a good university rather than doing an engineering of your choice, one you should like, at a not so good university, because the placement, which is the final kind of output of the entire education system, is the thing which matters. Even if you have scored very well, unless you get placed, it is still, I mean, it's a challenge, and sometimes a scary thing for especially people at that age, that what will happen if I do not get placed. So with that, I would say engineering is a good choice for the future, and then I'm open to questions and answers. So the students know that they can chat with me on the. You can use the chat window to send me your questions. I will give you an honest answer. There is a question by Saurav Kangurde where he is asking about mechatronics engineering. Okay, so as I mentioned, mechatronics is a amalgamation or a combination of mechanical, electronics, perhaps some embedded software, and even communications. A very good example of that would be robots. Robots used for automated manufacturing, where you are using all the different principles in order to manufacture a product. So it's quite interesting. I mean, what I'm trying to say here is that if you were to choose, let's say you are an industry and you are making a product, in a standard way of doing things, I will have to hire a mechanical engineer, I have to hire an electronics engineer, I have to hire a design engineer, a software engineer, and a communications engineer separately in order to have all the capabilities in order to make the product. But if I were to hire just one mechatronics engineer, perhaps he will come to the industry with all those different skills together and like a finished product. So from an efficiency point of view, a mechatronics engineer will be more efficient for an industry. However, it does depend on what kind of industry, what kind of specialization, and then we will see. There are specializations in the mechatronics engineering, there's robotics. So, depending on the kind of industry you are focusing or you want to focus, you can choose those elective specializations. If you are interested in the recruiters for mechatronics, oh, there are plenty. In fact, almost all the automobile engineers, the automobile companies like Maruti Suzuki, Tata, MAN, Cummins, Caterpillar, Honda, each one of them takes engineers from mechatronics also. Computer science future. There is a question on computer science future. Well, what to say? Computer science is dealt by our School of Computer Science, and to ask a question about what is the future of computer science is a very, very big question. There are several aspects of computer science, and as of today, I know the trending aspects are big data, which is like analyzing lots of amounts of data. Like for example, let's see what is the practical application. It is clear in the oil industry that in order to make the next level of efficiency, we need to integrate the operations together in one big software. For example, we cannot no longer have a separate drilling company, a separate logging company, a separate production company. No, if you have separates where technology and people are in separate silos, then it is not efficient. And as you have seen in the petroleum industry, because of the current market price, the name of the game is efficiency. The oil price is low, so if you want to make money, you have to be more efficient. And one of the ways of becoming more efficient is to be able to integrate all the services. So when we say integrate, the question becomes that okay, so how do we do that? It is not so easy. You have to make a platform for integration. And that platform for integration is perhaps what most of the companies are currently working on, which could be a software platform where the data from different aspects of oil and gas industry are brought together in one big place. And then that one big place will have lots of data. Then to acquire the data which you need will be another challenge, and to do it in an efficient way will be the next level of things, as I said. So from a computer science point of view, I mean, there is no limit. There is robotics, there is artificial intelligence, there is manufacturing automation, plenty of different upcoming and exciting things are there. What I'm trying to say here is that don't get yourself hooked up with just Facebook and Google. Look, these are not these are not I mean, of course there are some people who have careers in Facebook and Google, but I mean, what I'm trying to say is those are not what computer science is all about. Computer science is much more than social media. As I mentioned that I have spent 30 years in the industry. I am now in academics, so I can give you an honest answer to each one of your questions from both points of view, from the industry point of view, from an academic point of view. So whatever questions you have, you can go ahead and ask. Future of robotics and avionics. Okay, so the future of robotics and avionics. There are two types of robotics. Let's first look at industrial robotics, because that is where the most of the meat of the things are going to be. I have mentioned to you that one of the trends which is picking up in these days is industrial automation. When I say industrial automation, it's pretty much like almost everything will be built by robots. But then the issue will be that how do you make these robots? And these robots are industrial robots. You must have seen in some movies how they make cars these days, how they make any product these days. So from that point of view, yes, robotics has got an immense scope. I mean, it is almost like we know for sure that it has got immense scope. Then there is a part of robotics which is like the defense applications, and where you build robotic weapons and robotic vehicles. So that is another application. I am not very clear on that how well or how good we are going to do on that, but I am pretty much sure that industrial automation is definitely going to be a trending thing in the next decade or so. Then coming to avionics. Avionics is a very interesting thing. As I mentioned to you, avionics is that part of electronics which is to do with aircrafts, and it kind of includes a little bit of space technology, a little bit of GPS, a little bit of electronics engineering, a little bit of software, a little bit of embedded systems. So another interesting thing. However, one thing you must know, that as of today we do not do a lot of avionics ourselves. The only avionics which is being done is by the defense, which is building some of the infrastructure for making aircrafts and avionics. I mean, let's look at it this way. To be honest, aircraft industry, if you look at passenger aircrafts, there are only two or three big names. There is Boeing and there is Airbus. Boeing is American, Airbus is European. So pretty much a lot of the commercial passenger aircraft avionics resides over there, and we do not have access. We as Indians do not have access to it. The way we can have access to it is when we start manufacturing these aircrafts in India. And as I mentioned to you, Boeing is I mean they're going ahead with a joint venture. Airbus, I'm not very sure how that future this thing is coming up. But one thing we know is that our defense has tremendous needs. Air defense has tremendous needs. So there are a number of companies like Lockheed Martin, etc., who are interested, like Bombardier, who are interested to make or partly make the products in India. When that happens, then we will get access to the avionics, and then we will be able to design new avionics. So as of today, I would say avionics is pretty much a bought item. For example, just like you buy Windows software, it is there, you just use it. But once you start making the aircrafts in India, then you will get into that position where you will be designing the avionics yourself, and that will be very interesting. So perhaps it is time, perhaps it is a something which is going to happen in the next 2 3 years, definitely. So yeah, it will be a good and interesting engineering to learn, and by the time you finish your engineering and come to the industry, most likely their requirement will be there in the industry, plenty of requirement. However, let me also say, do not look at India only, look at global. There, as I have mentioned to you, India today produces the maximum amount of young engineering, maximum amount of young talented workforce. So even if India, the requirement in India does not grow so much, there will be a requirement globally. And because there are not many people available globally, because their population rates are going down, the amount of skill required is different, and they do not have the infrastructure to develop that skill, or they do not want to do that. Whatever be the reason, one of the things which is definitely going to happen is that if you have that knowledge, if you have the skill, you will be in demand, whether in India or whether it's globally. Avionics is not going to go away. Aircraft industry is only going to become bigger and bigger and bigger. Okay. Thank you guys. Thank you very much.